This podcast is going to give you a brief introduction to the periodic table and how it's organized. Um, and how it's organized. So first look at the periodic table. This guy here is named Mendeleev. So by the end of the 18th century, Lavoisier compiled a list of 33 known elements. And just to give you an idea of how quickly they were discovered, by 1870 there were 50 elements known. By 1925 there were 80, and today there are 118. So Mendeleev lived right around this time here. There were about 50 to 60 known elements. So what Mendeleev did was organize the known elements by their properties. And what he did was make groups or columns where all the elements in one group would do similar things, like all react with water, all be inert, all have the same basic properties. What he also did, which is what made his paper so special, was there were some, rather than try to make everything fit, he actually left some holes in his periodic table. How to see one, where he had question marks. And he predicted properties of elements that would go in those places. That he predicted that there would be elements that would be found that would fit in his periodic table, or missing elements. And then later on, those elements were discovered. So the properties that he predicted, they turned out to be true. So they went back and looked at his paper and said, wow, there must be something to this. So that forms the basis of our modern periodic table. So today, the big difference between Mendeleev's table and ours is that today they're arranged by atomic number. He didn't know about atomic number. He arranged them by mass. But now we know that the atomic number is the number of protons, and that's how the modern table is arranged. So here's some information about how it's organized. We've got horizontal rows, which we call periods, and the periods go across. So the first period would just have H, hydrogen, and helium. That's period 1. The second period would be the second row, which is lithium, beryllium, boron, carbon, nitrogen, etc. Third period, sodium, magnesium, aluminum, etc. The vertical columns are called groups. So these are all in one group, one column. Beryllium, magnesium, calcium, strontium, that all makes one group. If we look on over here, we've got the blues here, helium, neon, argon, krypton. That's all one group. So each column is a group, and they have a numbering system at the top. There's a couple different ways to number them. The way that it's done now is this is group 1, 2, 3, 4, all the way across the periodic table, ending up at 18. And that's how most periodic tables today are numbered. There's also the A and B numbering system, where the first 2 groups are A groups, as well as the last 6. Those are the A groups, and the B groups are found in the middle. And this table here, as well as the one that you have, has both numbering systems on there, but we usually refer to them by the group number 1 through 18. So again, the A groups, groups 1, 2, and 13 through 18. So these 2 skip the middle and the final 6. The B groups are the middle groups, 3 through 12, and those come here. So the B groups also are called transition metals. These yellow ones in the middle, B groups, transition metals. Make sure you have that in your notes. And then the bottom 2 rows, which are down here, are called the inner transition metals, or the rare earth elements. And they are very rare. We hardly ever use them. So family names, there's some groups that have special family names which you need to know. Group 1, alkali metals. That's these guys here. Not hydrogen, because hydrogen's not a metal, but the rest of these red guys, alkali metals, right here. Group 2 is the alkaline earth metals, which is the second group over. Alkaline earth metals, and that's beryllium, magnesium, calcium, strontium. Group 17, second to the last group, this aqua blue color here, halogens, fluorine, chlorine, bromine, and iodine. Those are the halogens. And group 18, which is the final group, last group, noble gases, helium, neon, argon, krypton, xenon, radium. They are all gases, and they don't react with anything, so that's why they called them noble gases. Metals are on the left side of the periodic table. Most elements are metals, so these are all metals. Remember the middle group, the B group, is the transition metals. Non-metals are on the right. That's where all the gases live. Noble gases, halogens, those are all non-metals up here. And in the middle, we have a stair step. So this red line, make sure you have this in your notes. This is the dividing line between metals on the left, non-metals on the right. And what happens is, along the stair step, the elements that are yellow, boron, silicon, germanium, these elements here we call metalloids. And they have some properties of metals and some properties of nonmetals. They sort of are in the middle. Along the stair step are the metalloids. Make sure that you have those circled in your notes or indicated in your notes. Aluminum's a little bit weird because it's along the stair step, but it is a metal. It is not a metalloid. So make sure you have that clear in your notes.